Hello and welcome back. So today we'll get back to GCP Essential Google Cloud Infrastructure. We'll take the foundation course from the exact same place where we left the last time, which is the module on virtual machines. So until now we covered, uh, virtual networks, and possibilities of interactions with Google Cloud. Now we'll continue with this module about virtual machines. Let's go.
In this module, we
Oh, so let's change the output.
cover virtual machine instances or VMs. VMs are the most common infrastructure component, and in GCP, they're provided by Compute Engine. A VM is similar but not identical to a hardware computer. VMs consist of a virtual CPU, some amount of memory, disk storage, and an IP address. Compute Engine is GCP's service to create VMs. It is very flexible and offers many options, including some that can't exist in physical hardware. For example, a micro VM shares a CPU with other virtual machines, so you can get a VM with less capacity at a lower cost. Another example of a function that can't exist in hardware is that some VMs offer burst capability, meaning that the virtual CPU will run above its rated capacity for a brief period using the available shared physical CPU. The main VM options are CPU, memory, disks, and networking. Now, this is going to be a very robust module. There's a lot of detail to cover here with how virtual machines work on GCP. First, we'll start with the basics of Compute Engine, followed by a quick little lab to get you more familiar with creating virtual machines. Then, we'll look at the different CPU and memory options that enable you to create different configurations. Next, we'll look at images and the different disk options available with Compute Engine. After that, we will discuss very common Compute Engine actions that you might encounter in your day-to-day job. This will be followed by an in-depth lab that explores many of the features and services covered in this module. Let's get started with an overview of Compute Engine.
Okay, so in reality, we have two labs. Let's go.
As mentioned in the introduction to the course, there is a spectrum of different options in Google Cloud for compute and processing. We will focus on the traditional virtual machine instances. Now the difference is, Compute Engine gives you the utmost inflexibility, run whatever language you want, it's your virtual machine. This is purely an infrastructure as a service or IaaS model. You have a VM and an operating system, and you can choose how to manage it and how to handle aspects such as auto scaling, where you will configure the rules about adding more virtual machines in specific situations. Auto scaling will be covered later in the course. The primary work case of Compute Engine is any generic workload, especially an enterprise application that was designed to run on a server infrastructure. This makes Compute Engine very portable and easy to run in the cloud. Other services like Google Kubernetes Engine, which consists of containerized workloads, may not be as easily transferable as you are used to from on-premises. So, what is Compute Engine? At its heart, it's the physical servers that you're used to running inside the Google Cloud environment, with a number of different configurations. Both predefined and custom machine types allow you to choose how much memory and how much CPU you want. You choose the type of disk you want, whether you want to use persistent disks backed up by the standard hard drives or solid state drives, local SSDs, cloud storage, or a mix. You can even configure the networking interfaces and run a combination of Linux and Windows machines. We will discuss these options in more detail later in the course.
Predefined or custom machine types. So let's open Compute Engine. Okay, for any workload. Options. So we have predefined and custom machine types. Okay. Predefined. Imagine that predefined are all the predefined models, like with these lettered series. And then we have the customs. Okay.
We will discuss the
Covered throughout this.
more detail later in the course.
Several different features will be covered throughout this module, such as machine right-sizing, startup and shutdown scripts, metadata, availability policies, OS patch management, and pricing and usage discounts. It is important to mention that hardware manufacturers have run up against limitations, and CPUs, which are central processing units, and GPUs, which are graphics processing units, can no longer scale to adequately reach the rapid demand for ML. To help overcome this challenge, in 2016, Google introduced the Tensor Processing Unit, or TPU. TPUs are Google's custom-developed application-specific integrated circuits used to accelerate machine learning workloads. TPUs act as domain-specific hardware, as opposed to general-purpose hardware with CPUs and GPUs. This allows for higher efficiency by tailoring architecture to meet the computation needs in a domain, such as the matrix multiplication in machine learning. TPUs are generally faster than current GPUs and CPUs for AI applications and machine learning. They are also significantly more energy efficient. Cloud TPUs have been integrated across Google products, making this state-of-the-art hardware and supercomputing technology available to Google Cloud customers. TPUs are mostly recommended for models that train for long durations and for large models with large effective batch sizes. Refer to the documentation for more details. Let's start by looking at the compute options. Compute Engine provides several different machine types that we'll discuss later in this module. If those machines don't meet your needs, you can also customize your own machine. Your choice of CPU will affect your network throughput. Specifically, your network will scale at 2 gigabits per second for each CPU core, except for instances with 2 or 4 CPUs, which receive up to 10 gigabits per second of bandwidth. There is a theoretical maximum throughput of 200 gigabits per second for an instance with 176 vCPU when you choose an C3 machine series. When you're migrating from an on-premises setup, you're used to physical cores, which have hyperthreading. On Compute Engine, each virtual CPU or vCPU is implemented as a single hardware hyperthread on one of the available CPU platforms. For an up-to-date list of all the available CPU platforms, refer to the CPU Platforms documentation link in the course resources. CPU Platforms documentation link.
So talking about network throughput in Compute Engine. I have read that for each virtual CPU, I will add the throughput will increase by 2 gigabits per second. Did I understood correctly? Are we talking about processing speed, number of operations? A VM with one CPU can have up to 2 gigabits per second of network bandwidth. A VM with 4 CPUs can have, there's an exception to this.
Or vCPU on one of the or an up-to-date platforms won't meet your needs. Typically, your network will scale at 2 gigabits per second for each CPU core, except for instances with 2 or 4 CPUs, which receive up to 10 gigabits per second of bandwidth.
Okay, so from 6 CPU, this calculus is correct. The maximum is capped at 100 GB for certain machine time, regardless of number of virtual CPU. It says 200, but okay. It's not about processing speed. The virtual CPU processing power relates to how fast it can execute instruction, not how much data it can send or receive over the network. Actual throughput may vary. The actual throughput depends on various factors like VM machine type, network configuration, workflow patterns, and destination. This scaling mechanism ensures that the larger VM with more can handle higher network loads, which is especially useful for data-intensive applications like video streaming, large file transfer, distributed workload. Would you like full reconfiguration on example scenario? No, okay. Therefore, this is just the relation between the computation power and the bandwidth. It is fixed to that ratio because it makes sense. That number imagine the use cases of the VMs. Okay.
There is a theoretical maximum throughput of 200 gigabits per second for an instance with 176 vCPU when you choose an C3 machine series.
After you pick up your compute options, you want to choose your disk. You have 3 options: standard, SSD, or local SSD. So basically, do you want the standard spinning hard disk drives or flash memory solid state drives? Both of these options provide the same amount of capacity in terms of disk size when choosing a persistent disk. Therefore, the question really is about performance versus cost because there's a different pricing structure. Basically, SSDs are designed to give you a higher number of IOPS per dollar versus standard disks, which will give you a higher amount of capacity for your dollar. Local SSDs have higher throughput and lower latency than SSD persistent disks because they are attached to the physical hardware. However, the data that you store on local SSDs persists only until you stop or delete the instance. Typically, a local SSD is used as a swap disk, just like you would do if you want to create a RAM disk. But if you need more capacity, you can store those on a local SSD. Standard and non-local SSD disks can be sized up to 257 TB for each instance. The performance of these disks scale with each GB of space allocated. As for networking, we have already seen networking features applied to Compute Engine in the previous modules lab. We looked at the different types of networks and created firewall rules using IP addresses and network tags. You'll also notice that you can do regional HTTPS load balancing and network load balancing. This doesn't require any pre-warming because a load balancer isn't a hardware device that needs to analyze your traffic. A load balancer is essentially a set of traffic engineering rules that are coming into the Google network, and VPC is applying your rules destined to your IP address subnet range. We'll learn more about load balancers in a later course of the Architecting with Google Compute Engine series.
Okay.
Let me give you a quick walkthrough of the VM instance creation process and point out CPU, storage, and network options in the GCP console. So here I am already on the Compute Engine instance page. You can get to here by going to the navigation menu and then clicking on Compute Engine. And since we use this in the course a lot, you might actually want to pin this sometimes so that you can get to it more easily. And then within there, I have gone into VM instances. So I just want to, again, show you some of the options that are available when creating an instance. To get started, I'm going to click on Create. And the first thing I want to choose is a name. So you have that right up here. And then maybe more importantly is actually where you want the instance to be located. So you have an option of all the different available regions. It has a name of the regions as well as the closest city as to where that region is located. And then within the regions, you have different zones that you can choose from. You also see on the right-hand side that there is a cost associated with the current configuration. And that cost is going to change as we change the configuration. So for example, if I, instead of creating an instance in US Central 1, I create one maybe in Europe West 1, you will see that the cost is slightly adjusted. So I can try that a couple different ways by choosing different locations, and you should see that the cost changes depending on the region that we choose. Now, it goes further if I then choose the machine type. There are different types. We'll go into all of those. But if I go in here, the different types explain to me what they provide. This standard N1 Standard 1 provides one virtual CPU with 3.75 gigabytes of memory. If I change to a machine with more CPU and more memory, we'll see that the cost is adjusted. You can also go into details here. It actually spells it out for you that there's a cost for the CPU and memory, but there's also a cost for the persistent disk. We haven't configured that yet, but this is the default value, and if we configure that, it's going to adjust the cost. There's also sustained use discount. We'll go into that as well, but essentially all of that is what ultimately gets you to this total monthly cost. It's also broken down in an hourly cost here, and we'll talk more about pricing later within the module. So again, I can choose different machine types. Maybe I want a larger machine type, it's going to be more expensive. Maybe I just need a shared core, so something really a micro machine or a small machine, and that can really drive the cost down a lot. So let me go back to the default. And the other thing to think about in terms of your region and zone is not just the cost, but really, you want to create your instances that are close to your users. Maybe you want to have them spread out across different regions for high availability. You might have restrictions for data locality, meaning that your data has to be in a specific region. So these are all the different things that you want to consider when choosing the region and zone. Now, if I scroll further down, one of the next big options is the boot disk. So we can see here that currently it has a 10 gigabyte standard persistent disk. I can change that. I can change the image itself, but I can also change the boot disk type. Now, the boot disk needs to be a persistent disk. We have the standard persistent disk, think of an HDD, and we have the SSD. And you can see that we can define the size here, and you can see that both of them have the same exact maximum size. So if I make this larger, let's say 1,000, then we're going to see that the cost now is adjusted to that disk size. So I can go back, it's very large. Maybe I'm just okay with 10 gigabytes as the boot disk. You can also add more disks. So if I scroll down and go to Management Security Disk Networking, I can go to disks here. So here I can choose the type of encryption for the disk. I have Google Managed Key, Customer Managed Key, and Customer Supplied Key. And then I can add more disks. So if I add a new disk, here then under type, I could also choose a local SSD. These come in predefined sizes. Depending on how many you choose, your performance, as you can see down here, is going to get adjusted. There is a limit. So at some point, the more disk you choose, you're going to hit a limit in terms of your performance. And same if I choose an SSD disk and change the size here, you'll see that also there's a limit, but it's also adjusted if I scale this. You are changing the IOPS as well as the sustained throughput limit. Now, another important thing is obviously networking. So if I click on here, you want to choose the network interface. We already went into this a little bit in the previous module in terms of choosing your primary internal IP, choosing if you want an external IP or not. So those are all of the different options that you can get there. Now, what's really cool is this is all using the GCP console, but down the road you might say, well, I want to create these instances quickly, and I want to use a command line. Well, this user interface gives you the command line option. So it's spelling out exactly all the different options you've chosen, how you would recreate that using G-Cloud. So this can kind of help you get started using that command line and make you more comfortable using that command line. So let me just go ahead and create this instance. And once we create it, we have these different columns that are listed here. There are more columns that we can choose from. For example, when you created it, what the machine type is, what network this is a part of, if you have labels or other things. So lots of different options you can list here. So for example, I can list here when the machine was created, the type, as well as the network it is a part of. That's how easy it is to configure the location, CPU, memory, storage.
For accessing a VM, the creator of an instance has full root privileges on that instance. On a Linux instance, the creator has SSH capability and can use the Cloud Console to grant SSH capability to other users. On a Windows instance, the creator can use the Cloud Console to generate a username and password. After that, anyone who knows the username and password can connect to the instance using a remote desktop protocol or RD.
Solo file shell, your third-party client, and generate key pair.
RDP client. We've listed the required firewall rules for both SSH and RDP here, but you don't need to define these if you're using the default network that we covered in the previous module.
The lifecycle of a VM is represented by different statuses. We will cover this lifecycle on a high level, but we recommend returning to this diagram as a reference. When you define all the properties of an instance and click Create, the instance enters the provisioning state. Here, the resources such as CPU, memory, and disks are being reserved for the instance, but the instance itself isn't running yet. Next, the instance moves to the staging state where resources have been acquired, and the instance is prepared for launch. Specifically, in this state, Compute Engine is adding IP addresses, booting up the system image, and booting up the system. After the instance starts running, it will go through pre-configured startup scripts and enable SSH or RDP access. Now, you can do several things while your instance is running. For example, you can migrate your virtual machine to another host in the same zone instead of requiring your instance to be rebooted. This allows Google Cloud to perform maintenance that is integral to keeping the infrastructure protected and reliable, without interrupting any of your VMs. While your instance is running, you can also move your VM to a different zone. Take a snapshot of the VM's persistent disk. Export the system image. For example, you can migrate your virtual machine to another host in the state. Compute Engine is adding IP addresses, booting up the system image, and booting up the system. After the instance starts running, it will go through pre-configured startup scripts and enable SSH or RDP access. Now, you can do several things while your instance is running. For example, you can migrate your virtual machine to another host in the same zone instead of requiring your instance to be rebooted. This allows Google Cloud to perform maintenance that is integral to keeping the infrastructure protected and reliable, without interrupting any of your VMs. While your instance is running, you can also move your VM to a different zone. Take a snapshot of the VM's persistent disk. Export the system image, or reconfigure metadata. We will explore some of these tasks in later labs. Some actions require you to stop your virtual machine. For example, if you want to upgrade your machine by adding more CPU. When the instance enters this state, it will go through pre-configured shutdown scripts and end in the terminated state. From this state, you can choose to either restart the instance, which would bring it back to its provisioning state, or delete it. You also have the option to reset a VM, which is similar to pressing the reset button on your computer. This action wipes the memory contents of the machine and resets the virtual machine to its initial state. The instance remains in the running state through the reset. The VM may also enter a repairing state. Repairing occurs when the VM encounters an internal error or the underlying machine is unavailable due to maintenance. During this time, the VM is unusable. You are not billed when a VM is in repair. VMs are not covered by the service level agreement while they are in repair. If repair succeeds, the VM returns to one of the above states. Finally, when you suspend the VM, it enters in the suspending state before being suspended. You can then resume the VM or delete it.
There are different ways you can change a VM state from running. Some methods involve the Cloud Console and the gcloud command, while others are performed from the OS, such as for reboot and shutdown. It's important to know that if you're rebooting, stopping, or even deleting an instance, the shutdown process will take about 90 seconds. For a preemptible VM, if the instance does not stop after 30 seconds, Compute Engine sends an ACPI G3 mechanical off signal to the operating system. Remember that when writing shutdown scripts for preemptible VMs. As I mentioned earlier, Compute Engine can live migrate your virtual machine to another host due to a maintenance event to prevent your applications from experiencing disruptions. A VM's availability policy determines how the instance behaves in such an event. The default maintenance behavior for instances is to live migrate, but you can change this behavior to terminate your instance during maintenance events instead. If your VM is terminated due to a crash or other maintenance event, your instance automatically restarts by default, but this can also be changed. These availability policies can be configured both during the instance creation and while the instance is running by configuring the automatic restart and on-host maintenance options. For more information on live migration, refer to the link section of this video. OS updates are part of managing an infrastructure. Let's see how we can manage the updates to a fleet of Windows VMs. When you provision a premium image, there's a cost associated with this image. This cost includes both the usage of the OS, but also the patch management of the OS. Using Google Cloud, we can easily manage the patching of your OSs. Managing patches effectively is a great way to keep your infrastructure up to date and reduce the risk of security vulnerabilities. But without the right tools, patching can be a daunting and labor-intensive process. Use patch management to apply operating system patches across a set of Compute Engine VM instances. Long-running VMs require periodic system updates to protect against defects and vulnerabilities. The OS Patch Management Service has two main components: Patch Compliance Reporting, which reports insights of the patch status of your VM instances across Windows and Linux distributions. Along with the insights, you can also view recommendations for your VM instances. And Patch Deployment, which automates the operating system and software patch update process. A patch job runs across VM instances and applies patches. There are several tasks that can be performed with patch management. You can create patch approvals. You can select what patches to apply to your system from a full set of updates available for a specific operating system. You can set up flexible scheduling, so you can choose when to run patches, one-time or recurring schedules. Apply advanced patch configuration settings. You can customize your patches by adding configurations such as pre- and post-patching scripts. And you can manage these patch jobs or updates from a centralized location. When a VM is terminated, you do not pay for memory and CPU resources. However, you are charged for any attached disks and reserved IP addresses. In the terminated state, you can perform any resources. However, you are charged dates from a centralized location. When a VM is terminated, you do not pay for memory and CPU resources. However, you are charged for any attached disks and reserved IP addresses. In the terminated state, you can perform any of the actions listed here, such as changing the machine type, but you cannot change the image of a stopped VM. Also, not all of the actions listed here require you to stop a virtual machine. For example, VM availability policies can be changed while the VM is running, as discussed previously. You can perform any of the actions listed here.
Change machine type, migrate VM to another network, other remove attached disk, change how to delete settings. So change network, change disk, change machine type, modify instance tags, modify custom VM or project-wide metadata, remove or set a new static IP. Okay, and modify VM availability or policy. Okay, let's go.
Let's take some of the compute engine concepts we just discussed and apply them in a lab. In this lab, you explore virtual machine instance options by creating several standard VMs and a custom VM. You also connect to those VMs using both SSH for Linux machines and
Let's go 1 hour. I hope to do it in 20 minutes. 5 credits, guys. Okay, incognito. So let's go. We have it. I want it in English. Okay. Yeah. Then task objectives. This lab creates several standard VMs, create advanced VMs, set up. Task 1. Create instance for name type, a name for your instance. Hover over the question mark icon for advice about what constitutes a properly formed name. I will just put VM1. East4 is for A. It is E2. For machine type, click. Okay, for machine type, medium. Click advanced options. Okay, so we'll leave it E medium. Okay, so VM create instance. Okay, I will just leave this name for the instance. Then US is for A. Machine configuration E2. So we have an E2 medium. Let's try to put E2 standard 4. So the price is 111. Okay. So shard core, here we are sharing the computational power. Instead, here we're not sharing it. Therefore, there's a higher cost. Okay, we'll leave this one, and then we have to go to advanced networking interface. Networking interfaces. Select known for external IPv4 address. IP stack, internal, external, known. Okay. Click done. And then create. Okay, so now we go to the VM we just created. We need some seconds more. It should be ready. Okay. Now it says locate CPU platform and note the value. CPU platform. I will take a note about this Intel Broadwell. Click edit. Notice that you cannot change the machine type, the CPU platform, or the zone. You can add network tags and allow specific network traffic from the internet and firewalls. Some properties of a VM are integral to the VM, are established when the VM is created and cannot be changed. Other properties can be edited. You can add additional disks, and you can also determine whether to boot disks, whether the boot disk is deleted when the instance is deleted. Normally, the boot disk defaults to being deleted automatically when the instance is deleted, but sometimes you will want to override this behavior. This feature is very important because you cannot create an image from a boot disk when it is attached to a running instance. So you will need to disable delete boot disk when the instance is deleted. Examine availability policies. You cannot convert a non-preemptible instance into a preemptible one. This choice must be made at the VM creation. Preemptible instance can be interrupted at any time and is available at a lower cost. If the VM is stopped for any reason, for example an outage, the automatic restart feature will start it back. Is this behavior you want? Are your application idempotent? Written to handle a second startup properly. During host maintenance, the VM is set for live migration. However, you can have the VM terminated instead of migrated. Okay, so cancel, explore VM logs, VM instance details, purge your VM, click logging. Okay, click the expand this log entry icon to left on lines to see the kind of information it contains. Okay, next, done, got it. Expand this log entry icon to the left of one of the lines to see the kind of information it contains. So the kind of information we have here. Let me see how we can. Okay, so we can expand this. Okay. Now, one of the lines is just this one, for example, the first. So we have a lot of description of the event, the timestamp when this happened, the resource on which this happened, a lot of identification of jobs or resources on which the jobs have been executed. Create a Windows virtual machine. So now we'll create another VM. Okay. Create instance. Let's go. US is for a E2 standard. Standard 2, yeah. Boot type, boot disk change. So Windows Server public images operating system. Windows Server. Windows Server 2016 Data Center Core. SSD persistent disk. Then 64 gigas. Click select. For firewall, allow HTTP and HTTPS. Click create. When the VM is running, notice that the connection option in far right column is RDP, not SSH. You will need the RDP client installed on your local machine to connect to the Windows desktop. Yeah, okay. Set the password for the VM. So click on the name of your VM, Windows VM, to access the VM instance details. You don't have a valid permission, a valid password for this Windows VM. You cannot log into the VM Windows without the password. Set Windows password. Which section is this? Variable. Set Windows password. Oh, okay. Okay, it looks like it has been set. Okay. The following is the new Windows password for copy and okay, copy. Now, how do we continue? Okay, so task 3, create a custom virtual machine. It's kind of boring. This lab is just creating virtual machines and not really doing anything with them. Machine type, custom, but wait. So here is for, okay, course, 2 virtual CPUs, and memory 4 gigas. Okay, so we'll leave bookworm and create. Connect via SSH. To see information about unused and used memory and swap space on your custom VM, run the following command. Okay, so I will SSH into this. Okay, so I already launched the command, which will tell me the memory situation. Okay, to see details about the RAM installed on your VM, run the following command. Oh, wow. Okay. Size 4 gigas. And the memory, free memory here. Nearly, so it's nearly 4 gigas. Number of processors. To see details about the CPUs installed on your VM, run the following command. Okay. Let's exit from here. Progress. Review the lab. Just end the lab. It was really boring. Boring. They will know it. So let's go. Lab review.
In this lab, you created several virtual machine instances of different types with different characteristics. Specifically, you created a small utility VM for administration purposes, a Windows availability, just because we want to create a Windows machine. And specifically, the lab is instructing me to look for the Windows server.
Go.
Now that you have completed the lab, let's dive deeper into the compute options that are available to you in GCP by focusing on CPU and memory. You have 3 options for creating and configuring a VM.
So I will not continue in this moment. I will divide this compute virtual machines module in 2 videos. For now, I will stop. So next time, in next video, we'll resume from this exact video. See you the next time.